Hi, everyone. I'm sorry if you did try to join earlier. We had a power cut here and it was a little bit difficult for me to get online because there was no power for the internet or the computer. So apologies that we're starting late, but I thought I'd just come on in case there's anybody here who has some questions and we can go through those. So before I go through anything on the presentation, is there anybody online who has any questions? If you just pop them in the Q&A, I'll go through a couple of slides as normal, just to give you guys time to type if there is anything, and then we can go from there and wrap up when we're done. Just going to share the screen. Sorry, it's not behaving. Okay, so you should be able to see my screen now. Okay, so welcome to Process Safety with Louise. If you haven't joined us before, just a reminder of what this is. This session is being streamed live to YouTube and it will be available for playback on the YouTube channel. So just be mindful and respectful because whatever is said here will be available on the internet afterwards. It is a free session, so I am volunteering my time as well as anybody else on the call who may give you advice as well. So just be mindful of that when you're responding. It's a place to get industry experts and ask specific questions on process safety. It's available for catch up on YouTube, and you can also share your best practices in different areas. So we started a bit late, and apologies for the technical issues. What I'm going to do today is I'm going to go through a couple of incidents that have happened and reflect on them and see how we could have done better. And then I'll open the floor for the questions. So the first one is this incident which happened on Christmas Eve this year. And so I saw this come up on LinkedIn when I was actually talking to some of my family who live near Boksburg. So yeah, an LPG road tanker was driving, and you can see the bridge here. It was driving under the bridge, and the bridge was too low. And as it was driving, it got stuck, and the friction of getting stuck and the lost containment of liquid petroleum gas resulted in a fire. Several firefighters or 2 firefighting trucks were called to the scene, and they were responding to the fire when, unfortunately, there was a large loss of containment and the tanker ruptured. At that point, 15 people were fatally wounded, potentially more since the report that I read. And again, here, what has happened is emergency services are responding to the incident, but they've actually, in responding to the incident, put themselves in harm's way. An incident from a long time ago, Texas City ammonium nitrate, 1947. What had happened here is that there was a shipment of ammonium nitrate came in and it started to set fire. They were concerned about the fire, so they started to fight it with water, but they were concerned that if they continued to fight it with water, it would ruin the rest of the shipment. Unfortunately, after that, there was a detonation and several hundred people were fatally wounded in that incident, as well as several buildings. So what could have prevented it? A lot of the incidents that we look at, the fatalities, there may be a small number of fatalities from the initial event. For example, Texas City, Piper Alpha, it had 3 fatalities from the initial incident, but it was that escalation or the failure to respond to the emergency in an appropriate manner which resulted in a significant increase in number of fatalities. And there it went from 3 to 167. Okay, so the message that I wanted to share this month was that if you have emergency plans, go and have a look at them. Are you testing them on a regular basis? Do you know that they will behave in the way that you want them to behave when you have an incident? That is, have you trained people? Have you made sure that the facilities that you require are actually in place so that you would be able to respond in that way. There's another incident which is on the CSB website where there was a loss of containment at a drain connection. Again, quite flammable fluid, and that resulted in a fire. Unfortunately, they were unable to respond to the fire because the fire water valves were too close to the fire. And so they were not able to de-isolate the ring main at that point. And also they were not able to isolate the inventory because there was insufficient isolation provided between the source, which was the large column with a lot of liquid inventory, and the leak point, which was the drain valve. So there's a lot of incidents and a lot of history, which shows that even if we have really good process safety management and we feel like we have good control, we should always plan for the worst. Because if we don't plan for the worst, when it does happen, things can become exponentially worse and very quickly. Okay. And this can also extend to, for example, if you have an approach to be tolerant of asset damage, but not tolerant of people or environment damage, you may also have different things built into your emergency plan. So just make sure that you pick up that emergency plan sometime this year. You go through it, you test it, and test as well the external services. So quite often those links between the internal and external are not working. So for example, the video Fire in the Night from the CSB, one of the things that happened there was it was a long time before the external services knew what the incident was within the fence. They had a large inventory of methyl isocyanate, which is the same chemical which fatally wounded so many people at Bhopal. They were not sure whether that was contained or not. And actually that had been impacted during the initial incident, and which should have resulted in evacuation of people in the neighboring area. But because the communication had not been set up in a constructive manner, unfortunately, that couldn't happen. And so they were not evacuated. Fortunately, there was no loss of containment of that inventory, but if there had been, there would have been a significant number of fatalities. Okay, so again, the same message as before. We really want to learn from the past. We need to identify those hazards. We need to understand them and manage them both during our normal operation, but also potentially during emergency operations. And be vigilant. Make sure that our systems are robust for whatever the situation is. There was another incident on the CSB, which was using refrigerated storage to store a chemical which would have a runaway reaction at room temperature. The emergency generator for that, unfortunately, was within the floodplain and it had flooded. And so they lost the refrigeration to that storage, and they had to do a controlled burn. But those are sort of things, especially with the change in the weather that we are seeing across the world, that we need to think about whether our emergency systems will continue to operate under the current environmental conditions that we experience. Okay, I'm going to open the floor now to see if there's any questions, and then I'll answer those. And if there's not any questions, then we'll wrap up for today. So I haven't had any questions through the Q&A or the chat, but if there is anybody on the line who has a question, if you just let me know. Hope you've all had a good festive period. And if you were in the US, that you weren't too cold and you were able to keep warm, because I know that the temperatures there were very low over the festive period. I'm going to mute myself and put the video off. Oh, now I've got a question. So I've got a question from Pier Paolo. Is there a mandatory frequency for an emergency drill? So as far as I understand, there is no mandatory frequency. However, in the UK, when you submit your safety case, or which if you're offshore, or your coma report, in there you will define what the frequency is for testing certain things. And when you're testing those things, what you're trying to do is to demonstrate the reliability of those things, either your equipment or your emergency response. You're trying to demonstrate the reliability of that And you have to do that at a certain frequency to be able to achieve the risk reduction that you're looking for. So in the UK, whatever frequency you have set then becomes your frequency that you need to do it by. The same is true, I believe, in Norway, although they have got some more prescriptive requirements. In the rest of the world, I'm not sure. The frequency which I have seen offshore is that we will test, for example, the firewater system every 12 months. I think it was a wet test every 2 years and just a full test to make sure that the deluge valves will open every 12 months. The blowdown system had to be tested once a year, and there would be some partial testing on the blowdown valves in between that, which is also a critical part of the emergency response. And then the announcement system, I've seen those generally tested once a week. When we were offshore, we would test that when we did our muster, and we would be doing our emergency response checking then to make sure that people were able to use the equipment, the emergency line worked, people got into their equipment and did a rescue. But again, there we got people who are changing shift every 2 weeks. And so that means that they're practicing sort of twice in a month. Each shift is practicing twice in a month, or once in a month if they're transferring from day shift to night shift. So that's what I've seen historically for emergency response. But I'm not sure that any of that is mandatory, or if that's being deemed the appropriate response for emergency response in by the company, which then became mandatory in the UK. Does anybody have any other questions? One of the things which I often see on site visits is that when we start to test the emergency equipment, people, for example, testing the fire water, yes, water is coming out, the fire water is working. What we really need to be doing, which is the same as what we do with our instrumented protective systems, our relief valves, is we need to say, is it meeting the design intent? If the design intent is that it cools the vessel, we need to be able to, the water needs to be able to reach the vessel, and it needs to be delivering a certain liters per minute to the vessel and covering the vessel so that it can cool the vessel. If it is sheltering an escapeway, we need to make sure that it forms a curtain and it delivers a certain liters per minute so that it forms that curtain, maintains it, allows people to escape. If it is giving us time to escape, for example, passive fire protection, we need to make sure that that is going to last for the duration and type of fire, which can sometimes be overlooked. So when you're doing those testings, actually ask people, how do you know it is actually working in the way that it's supposed to be working and achieving that design intent? And that's really important to come back to that performance standard for each and everything that you're relying on in your bow tie. Okay, I've had another question. Emergency response plans are only for the fire. How can we make a plan against toxic? So your emergency response plans should not only be for fire. They should be for any incident which could result in either large loss of large asset damage, or large people damage, or large environmental damage. Your emergency response plans should be for all of those. If you look on the CSB website, there's a video called Mixed Connections. That video is really useful. It shows you about toxic response. So at that facility, they identified the potential for formation of a toxic cloud. They had detection within the control room, and they had the emergency equipment in the control room. However, because people were not going to their own emergency equipment, they decided to lock their rebreathers in a cupboard. And when they locked them in the cupboard, actually, when they needed them on this case where there was a toxic release, they couldn't get them out of the cupboard quick enough. But fortunately, they all managed to evacuate the building before they were fatally wounded. So they only had some breathing difficulties. But toxic should definitely be part of your emergency response. For example, at Bhopal, the risk was toxic there, and they had a scrubber system which was supposed to capture the methyl isocyanate in the water and take it off to a drainage facility, so it didn't impact the adjacent facilities. I have been on facilities where there's a toxic risk, and some of our emergency response drills are associated with toxic release. So making us put on our rebreathers, making us evacuate, muster in a safe location, checking the wind direction, and so on. So definitely, if your emergency response plans do not include toxic releases, you should have a look at that and see how you can change that. Okay. I've got another question. How could we increase efficiency for lessons learned from accidents, or what is the proper method or procedure to cover? So this year at the Hazards Conference, the message that I took away is that 95% of all major incidents in the industry with significant asset loss have already happened before. So the best thing that we can do is to make sure that we learn from the past. There are a few incidents which are new things which we didn't understand before, but majority of what's happened is happened before. So what we need to do really is to figure out how we can learn from the past. Now, fortunately, we do not have to go through all of the incident records and everything to be able to learn from the past and improve our design. But what we do need to do is we need to use the most up-to-date standards for our facility when we're designing and installing. Those standards include lessons learned from the past. Those standards are only updated every 10 years or so, depending on if there have been incidents, but those standards are the ones which form the basis of good design, and the updates to those have had to be agreed by several different parties, all with varying budgets for design. And so those standards should be seen as the minimum requirements, and we shouldn't be accepting designs which do not meet the minimum industry standards, which often we do. And often we don't actually check that our designs or our engineers are familiar with the standards. One of the key things associated with the standard use is that we actually have to identify the hazards associated with our facility to understand which standards to apply, right? Do we need active fire protection, passive fire protection, emergency escape routes, a temporary refuge? Well, we won't know those things unless we understand the hazards of our facility. So two things there is, one is there might be some standards associated with the type of equipment that you're using. Definitely use those because those incorporate lessons from the past. And the second one is to make sure that you have a robust management system for identification of hazards so that you can identify the correct standards to use. And then for learning from previous incidents, definitely look at things like the CSB. But the most important thing is when, for example, the way that I encourage learning from incidents is every time we have a HAZOP or a LOPA, a meeting associated with major accident hazards, every time I will have a safety moment at the beginning, we will have the safety moment and we'll have a time to reflect afterwards. And that reflection allows people time to embed the lesson. Also, I try to make sure that the learning from incidents is relevant to the study that we're doing, so that when we are going through the study, that lesson which they've learned in the morning can be replayed throughout the session, which often it is when we do our sessions, our HAZOPs, people say, well, this is like that incident that we watched earlier. Okay, so I hope that that helps. There's no easy way for learning from the past because obviously there's a lot of lessons and people have made a lot of mistakes. But for me, those are the places where I would start. Okay. I've got another question here. What are the measures and mitigation when we are developing a pre-fire plan against toxic? So really common, this depends on what your toxic risk is. In some cases, the toxic fluid is flammable, and so it would be preferable to ignite it rather than to let it reach the population, because the impact of ignition could be, say, in the order of 5 fatalities, whereas the impact from toxic release could be in the order of thousands of fatalities. It also depends on your location and the proximity to other equipment and other people. Some of the key measures or mitigations. So the first one is to know that you have the toxic release, right? You can't initiate any of those systems which respond to the toxic release until you know you have it. So having a good detection layout, and make sure that your mapping is sufficient, that it would identify the release, making sure that those detectors are suitable for your environment, and that they would work, and that you test them regularly. If you're finding you're having problems, you might need to change them for a different type of detector. The second one is making sure that people are practiced and drilled into what to do once a toxic release has been identified. Okay. And also having there's also a requirement to have some sort of proactive action for toxic releases. For example, there have been some incidents where there was a relatively small fire or a medium fire which started, which unfortunately then escalated to a toxic inventory, which was very close by, which then led to escalation. So making sure that you understand your scenarios in that location, and then taking appropriate measures for that relative to your hazard. If the toxic hazard cannot be managed through fire, potentially, for example, like the water curtain we discussed for Bhopal, also potential for rebreathers, the enunciation to allow people to know what to do. And if it has potential to impact the public, you need to engage the local community so that they know what to do when they hear the alarms. I hope that helps, but it really does depend on your hazard itself as to how you manage it and what your proximity is to that toxic release. I got another question from Cameron. How do we differentiate between fire strategy and toxic strategy? Also, do we use the fire hydrant present available in the fire effect? Can we take the credit as a mitigation measure? So as I've just mentioned, it really depends on the hazard and the proximity of the toxic hazard to the other hazards, for example, the flammable hazards on your facility. What I would say is that there will be some scenarios within your facility where the toxic hazard can be released without a fire, normally. For example, corrosion, overpressure, something like that associated with the vessel where toxic chemicals are stored. Then there will also be escalation events where the fire or some other initiating event escalates to the toxic release. Both of those need to be considered in your hazard risk management process, and the mitigations for those two will be different. Okay, and that's why it's so important to have that hazard identification and risk assessment process, so you can identify all the different ways in which this toxic release can happen, and you can make sure that you have appropriate barriers for each and every single cause, because the barriers you have for one cause might not be appropriate for the other cause. Okay, so making sure you have that. And what you're trying to do is to focus on the prevention side, preventing the toxic release, but you also need to make sure that you manage the mitigation in case there is one after. Okay. I've got another question. Okay, so this question is about being a Safety and Reliability Society member. The question is, how do I join? Well, there's an application form online. You do need some people to support your application. The preference is that you know somebody within the society, but if you do not know somebody within the society, if you have at least one chartered member of a different society who is supporting your application, then that application may be successful through the membership committee. Okay, so having a look on the website, there's an application form. It's not too long if you're just joining as a member. And there's different membership grades depending on your experience. But the resources available within the website are significant, and the webinars are always very well attended and very good content in different areas. Okay. And so another question about joining the Safety and Reliability Society and if it's good for a process engineer. So it depends on what you're trying to get out. So whenever I look at memberships that I'm joining, what I'm asking myself is, what am I getting from this membership? So I'm a member of several different international bodies. One of them is the Institute of Chemical Engineers. I'm a member of the Institute of Chemical Engineers because that is the professional body associated with my degree and my main area of practice. Also, I support the Institute of Chemical Engineers by providing training through their delivery. I'm a member of the Safety and Reliability Society because I think it's really important to get that cross-sector learning in the safety area. And in the Safety and Reliability Society, there's a strong connection with rail and nuclear, which then allows me to learn from others and other sectors which might have different experience, and also helps me share from my sector with others. Also in the Safety and Reliability Society, I found that I have a lot of opportunities to volunteer, which allows me different ways in which I can develop myself, which might be outside of my paid work. Allows me to develop skills which I cannot do within my paid work through my volunteer opportunities. And then I'm also a member of the Energy Institute because I use a lot of their publications for work that I do. Okay, so really having a look at what you're trying to get out of it. What is it that you're trying to achieve by putting this in? Because all of these institutes require your time commitment. You want to be making sure that your time is used to develop you appropriately. Okay, so as a process engineer, I would definitely encourage joining Safety and Reliability Society, but you know, that gives you a good grounding in different industries and helps you understand. But if that's not what you want to achieve right now, maybe you're looking at something different, there might be other societies that might be better for you. Okay. I've got another question. How do you determine realistic consequences from toxic release or asphyxiation during the HAZOP? So realistic consequences are really important in the HAZOP because the consequences that you define there will determine the further risk management that you take on. Normally, your procedures will define certain risk levels, then go on to certain further studies. However, what I found with HAZOP is it is really important to have those consequence modeling scenarios, those key consequence modeling scenarios available before the HAZOP, and to have a facility layout, marking up where those key inventories are. So now you can use the information from the consequence modeling, you can use information about the normal occupancy and the length of the release, and from there you can start to evaluate what you can do, you know, what the consequences can be. Typically look at the release at 60 seconds and the release at a continuous or after a long time, so that we can look at both, well, what could, within 60 seconds, it's very unlikely that we will have been able to evacuate anybody to prevent them having a toxic fatality. So within 60 seconds, that is the distance of the people who will be immediately impacted by the event. We then can have a look at the continuous, which might be even further. And those people we may have been able to evacuate before the toxic gas gets to them. And so that could be our escalation prevention. Also, those people who might be within the 60 seconds, those people we might want to give different safety devices and different training to those who are then outside. But have a look at what your company requires. If you have a difficult topology, you might want to do some 3D modeling as well. But in general, for the purposes of the HAZOP, assuming a flat surface, release at ground or above ground, depending on where the release is, and then laying that over the layout of the facility, that will help. But if you have some difficult topology, like they did in Bhopal, where the facility was up on a hill and the community was down in the valley, the toxic release with the heavy gas then filtered over to the population and killed everybody in their sleep. So just having a think about your area and where things would go is important. Okay, but that's typically what I do, and that's both for fire, explosion, and toxic. We need those results with a layout so that we can, in the HAZOP, we can make sure that we have the reasonable or the worst case credible consequence defined. Okay, I got another question. In a RAM study, do we only consider static and rotating equipment, or can we consider major and critical assets? In a RAM study, you can consider whatever you want, right? It depends on what you're trying to achieve. Are you thinking about your availability from all sorts of different things? So for an example I will take here is quite often people move towards installing a SIL 3 system, SIL3 instrumented system to protect them from a safety consequence, right? However, a safety instrumented system of level 3 only has a very short window under which you can maintain it while the hazard is present during a year. It's only 9 hours a year. If you need to do maintenance on that system outside of those 9 hours, you need to shut down or remove the hazard to allow you to do the maintenance. That might be a significant asset risk. And maybe when you look at that in a reliability study, you might think, well, actually, it might be better to do this other thing, which is more expensive on a capital wise, but it reduces, it increases our availability of our whole system rather than using the instrumented system. So that's an example where you might include that into our RAM study. Also looking at things like analyzers. So analyzers are not static or rotating, but analyzers, if they are used for instrumented protective functions, they can increase, they can reduce the reliability of our system or the availability of our system because they can be quite unreliable. So those are a couple of the ways in which we might want to include in our RAM study. But the scope of your RAM study depends on you as an asset, as to what you want to learn from it and what level of detail you want to go to. Obviously, you can go to a lot of detail, and that may or may not be appropriate to spend that money. Okay, I hope that helped. Okay, I've got another question here. Like any pump or vessel trip due to electrical failure, is that the case we can consider in the RAM? So this is related to the previous study. Also, what about wellhead and flow lines? Can they be part of the RAM study? And also, do we need a first asset critical analysis when we decide to take the RAM study apart from the RBD? Okay, so what I would say is it really depends on the risk, and that is the financial risk, i.e. loss of asset, but also the business interruption risk. Now, if you're operating on a service which is highly corrosive and you've decided to not go for a corrosion resistant alloy, you may want to include that in your RAM study. Yeah, and you might want to compare it to a system which did have a corrosion resistant alloy and see which was better. Okay, if there is a high reliance on some electrical equipment, for example, if you have all of your major equipment on one electric distribution board, you might want to consider that in the RAM study, because you would want to know, well, if that piece of equipment trips, the whole facility is down, right? So it's about understanding those consequences. For example, if you have 30 wells, the wellhead is unlikely to be part of the RAM study, because if one well goes down, there are still 29 others producing. If you have a produced water system, which has to be injecting the produced water, you only have one produced water well, well, then in that case, you might want to include the wellhead facilities in your RAM study, because if you are not able to dispose of your produced water to the produced water well, potentially, you are not able to produce, which then has a major impact on your business. So really understanding what those consequences are, then filtering those scenarios through to your RAM study is important. So it's not a straightforward answer, but it really depends on your risk, if that helps you. Okay, I've got a question here about HAZOP preparation. So what are some tips for HAZOP preparation? So one of the main tips is to do the preparation before you get to the workshop. One of the things that we need to do is to make sure all the documents are ready. So all the P&IDs, the cause and effects, the basis of design we have for reference, and so the alarm and trip register, we have all of that information, the layout. We also want to, so that's understanding the process and how it is operating and where it is located. We also want to have a good understanding of the potential consequences, which is what I referred to earlier about having that consequence modeling and having the layout and the occupancy defined before we start the HAZOP, so that when we get to the consequence definition, we understand. And then the third thing we want to understand is about the safeguards. So we might want to understand about their process safety time. We might want to understand about their effects, so using the cause and effects there. We might understand when they are initiated and so on. So those are the things we want to understand there. If we have a problem either in the initiating events, the consequences, or the safeguards, that's when we're going to start to get to recommendations. So anything that we can do to improve our understanding of those three That is where we want to be before we start the HAZOP. The other thing I would really encourage you to do before HAZOP preparation is to complete, for example, checklists on different equipment for engineering checks. So, for example, if you have a potential for overpressure and you have a relief valve, there needs to be no potential blockages between the source and the relief valve. Well, when we get into the HAZOP, we're going to find that and it's going to be an action. But that's a checklist thing that we can go through each node and we can say, okay, we've got a relief valve here. The source of pressure is this. Are there any blockages in between? Oh, yes, there is. We need to change the inlet nozzle for the relief valve. Okay, so those are things that we need to think about before we get into the HAZOP, because that minimizes the number of actions. And on my website, you'll see some checklists I've already prepared there for some typical equipment, which will help you do that pre-HAZOP checking. The other thing to do is to make sure that you've done the checks against the design standards. So whether that's in-company design standards or the industry standards, make sure you do that checking before you get into the HAZOP. Because I've been in many HAZOPs where we've completed the HAZOP and then everybody's gone, well, you know, that's really confirmed everything that we needed to do in the engineering standard. I'm like, we didn't need to do the HAZOP then, right? We knew the answers. We knew the answers. They're in the design standard. They're there because other people have learned from these mistakes. This is what they have learned that they need to do. In the HAZOP, if we identify everything, that's great. It means we're a really good HAZOP team. But actually, was that time well spent? We could have done that before we got into the HAZOP. Okay, so doing those checks, making sure you've got a sound design before you get in there, preparing your drawings, and then getting a full understanding of the causes, the consequences, and the safeguards before you get into the HAZOP. Making sure you have selected a good facilitator and that the sessions are booked and the rooms are prepared. All of that is really good practice for a HAZOP. I don't have any more questions at this time. What I'm going to do is I'm going to run through the wrap up. If another question comes up during that time, I'll answer it, and then we'll wrap up around 1:15. All right, I do have one more question now, so I'll answer that. In a HAZOP, we cannot take double jeopardy, even if during the workshop, operation team have several experiences where they have an incident due to human error and operator closing two valves at the same time as double jeopardy. What can we do here? Well, it wouldn't count as double jeopardy if you have past experience where operators have closed two valves at the same time. So an example of something which could previously have been described as double jeopardy, which is no longer double jeopardy, is, for example, blocking in a heat exchanger. So closing the suction and discharge of the cold side of the heat exchanger while the hot side of the heat exchanger is operating. That is now codified that is a relief scenario, regardless of whether you think that might be double jeopardy by closing it in. Because actually preparing the isolation of that equipment is an activity, right? We are preparing to isolate, and we've isolated it in the wrong way. We've made one mistake. We isolated the cold side before the hot side, and we resulted in the overpressure. So that, although it's two valves, it's not double jeopardy because it's an activity. So asking yourself the question, is this closing of two valves, is that because this is an activity, i.e. I'm preparing something for the next step and I close these two valves, but I've closed them on the wrong piece of equipment, right? Or I've closed them in the wrong part of the plant, or I've closed them in the wrong order. That's one mistake, following the procedure, but one mistake. Okay, so that's not actually double jeopardy there. So if you have some operator experience where they are doing these things, don't ignore that, because by arguing double jeopardy, because actually there's something wrong in your engineering design which is leading them to do this activity. Okay, and that's something that you have an opportunity to fix now before there is an incident. But if you pass that over and you just say no, it's not possible because it's double jeopardy, you've lost that opportunity to learn. So just taking sort of a pragmatic approach there would help. Okay, I'm going to share the screen again. Okay, so just having a look ahead at what's coming. So process safety with Louise, the next session is going to be March. I've got to skip February for work reasons. A reminder that we've got the TikTok channel and new videos will be loaded up to that. If you want to have some look at some resourcing, there is training, templates, auditing, and some free resources available on my website. And then we're going to be running some courses in February and March. We're running the HAZOP LOPA here in January, and we're going to run those again in February, March, because those have sold out in January. And then we'll also run some additional ones, process safety metrics, risk assessment. If there's any courses that you're particularly interested or any topics you're particularly interested in, please just let me know. And if we can fit those in, we will do. Okay. So I'm going to stop sharing there. I've got another following question about the double jeopardy. So double jeopardy means same equipment, they have suction and discharge valve, which are normally open, but the operator makes a mistake to close both. So that for me is not a double jeopardy because they are preparing that piece of equipment which has a suction and discharge valve for isolation. Okay. Or normally the suction is closed, right? So that you don't get the reverse flow through the pump, or the discharge is closed and they have inadvertently closed the other valve. So either of those are not double jeopardy for me, because the normal state for an offline pump would be either the suction or discharge closed to prevent the reverse flow through the pump, and then you've made one mistake of closing another valve, or you have prepared that piece of equipment for maintenance or for being offline by closing the suction and discharge. And so that event, which is not double jeopardy because it's one activity that you've done, then is the mistake. So neither of those I would say is double jeopardy. I would consider it in those two ways. Again, what you're trying to do with the HAZOP is not trying to do loads of different things, but what you're trying to do is you're trying to safeguard people from the most common things in which will happen. What you want to do is you want to make sure that if the operator makes one mistake, they will go home in the same condition that they arrived at work in. And so just discarding scenarios in the HAZOP by arguing double jeopardy, even though they're actually happening, how does that help the operator go home in the same condition they came in? It doesn't reduce the risk. Might make you feel better because it's not on the HAZOP record, but it doesn't reduce the risk. It doesn't make the operator any safer. And that's what we are trying to do here through all of our process safety studies. We're not trying to generate paperwork. We're not trying to generate evidence. What we're trying to do is we're trying to keep everybody who works on our facilities and everybody who will work on our facilities in the future and everybody who lives around them safe every single day. Okay, that's what we're trying to do. And so just ask yourself, are we achieving that objective here by discarding this scenario? And if you're not, then put it down. Okay. Well, thank you all very much. And thanks for your understanding about our technical issues that we had here today. I haven't had any more questions. So what I'm going to do is going to wrap up for today. And great to see so many of you here considering the delay. And I will see you guys again in March. Look after yourselves and take care. If you have any questions in the meantime, always get in touch on LinkedIn.